I've made mention of ATP numerous times already in these videos and the importance of glucose and oxygen. Everyone knows the importance of consuming oxygen and what happens when we are not able to get enough oxygen. The process that makes ATP is generally referred to as cellular respiration, which is a bit confusing at times because ATP can be produced in the cytosol of the cell, or it can be produced in the mitochondria of a cell. Keep in mind the mitochondria is an organelle within the cell, just like the nucleus, Golgi apparatus, endoplasmic reticulum, among others. And the reason I say it's a misnomer is because cellular respiration, the term respiration, is suggesting or connotating that oxygen is being utilized, which it certainly is many times when ATP is being produced. And it's the most efficient way to make ATP. We make a bunch of ATP when it is produced aerobically, that is to say, in the presence of oxygen. But ATP can certainly be made anaerobically as well. This video is going to be very brief. It's just going to outline what cellular respiration is, and in a subsequent video, we'll go into greater detail of all the sub-processes that allow our bodies to make ATP. Okay, so here's the basic equation for cellular respiration. Once again, if this is occurring in the cytosol of the cell, that is to say outside of the mitochondria, this doesn't necessarily apply directly because that can happen. That is to say, anaerobic respiration in the cytosol outside of the mitochondria can happen anaerobically in the absence of oxygen. And it certainly can happen in the presence of oxygen. But once again, we'll detail that later. I just want to focus on what we have right here. On the left side of the screen, C6H12O6 is the molecule of glucose. O2 is oxygen. So we have 6 oxygen molecules, and this is just to make this a balanced equation. Don't worry about how to balance it. If you remember from your chemistry on how to balance equations, which I'm not sure I can remember, go for it, or else you can just memorize the equation. So glucose plus oxygen are the reactants for this equation. The products are carbon dioxide, water, heat, and ATP. Now, the goal of this is to make ATP. That's the energy storage molecule. It's the molecule our body uses to impart energy in any sort of process that requires it. For example, moving ions or molecules against their gradients, muscle contraction, among a host of other things. Carbon dioxide, water, and heat are merely byproducts. They are not the goal. ATP is the goal of this equation. And I put heat in here. Oftentimes when this equation is written, heat will be left out, and I will leave it out at times. But it's important to understand what the products are, whether they're a byproduct or they're the main goal of ATP. Because we will see as we move forward in this course is that the more cellular respiration is occurring, the more heat is being produced, and that can have downstream impacts on the body, both good and bad. So glucose plus oxygen gives us carbon dioxide, water, heat, and ATP. Now, to be clear, if I was to make this a very complete equation, I should include ADP and this inorganic phosphate, the 1-phosphate. You couple the 1-phosphate to ADP and you get ATP. ADP is adenosine diphosphate, whereas ATP is adenosine triphosphate. Tri is suggesting 3 phosphates, di is suggesting 2. To make ATP, you need to couple the 1-phosphate to ADP. So truly, for a very complete equation, I should have somewhere on the left side of this equation ADP plus the phosphate, or I could have it above as I doing this equation. Oftentimes when I write it, oftentimes when others write it or books write it, it's not included, but it really should be. That's the bare bones of cellular respiration. More detail on this at a later time.